Well, good morning, everyone. My name is George Kaminsky. It's a pleasure to be here. I am a senior manager for database solutions at Nutanix, and I'm going to be uh, handling all the narration today, and I'm joined together by Chris Rogers, senior product manager for HYCU. Say hello, Chris.
Hi, everyone. Pleasure to be here.
Awesome. So today's topic is defend and recover with confidence, end-to-end cyber protection for databases. Now, before we get started, a quick note before we go too deep. We'd love to hear your questions. We are going to be covering some Q&A at the end of the session. So if you wouldn't mind using the Q&A button for any questions you have at the bottom of your Zoom display, that would be great. And as I mentioned, we'll have some time at the end for Q&A and we'll address all those questions there. So just use your Q&A button instead of the chat, and we'll get started. So we both want to begin by recognizing that, enterprises and financial services teams face immense pressure to make sure that databases are secure, fast, and always available. Databases are hard because they really contain the most sensitive intellectual property for companies today, which also makes them a priority target for hackers. We've seen examples where large amounts of accounts have been hacked and displayed, and that's the result of getting access to databases, right? Now, you may not think of HYCU and Nutanix as cybersecurity companies per se, and that's a fair assessment. But it's really important that you understand that we both have security capabilities that will provide a much more hardened environment to protect you and improve the database security posture. So together we offer proactive and reactive features and capabilities necessary for protection before, during, and after an attack. So we'll get started. So if you look at any research from Network World Magazine or SANS or Gartner, you'll get some type of a top 10 database security concerns. You'll see things that are very common that we hear about, like SQL injection attacks, which allow them to exfiltrate information from the database, weak password policies. A lot of these are configuration related, right? Unencrypted data. Well, that's because you didn't encrypt it, right, in your configuration. Lack of proper monitoring and logging, denial of service attacks are common. And a lot of these you require infrastructure level protection. Today, we're going to focus predominantly on the lower three, which is misconfigured database settings, outdated software and patches, and clean backup and data recovery, because those are relative to both Nutanix and HYCU, and most of this can be solved through automation. Before we get started, I just want to briefly mention, if you don't know Nutanix, we are a cloud platform. We provide application services end-to-end for enterprise apps, modern apps, all the way down through the infrastructure. We do this through a unified control plane and software that allows us to provide self-service, intelligent operations, federate the management of the infrastructure that our software Acropolis operating system runs on. We also have data governance capabilities, if you didn't know. That relate to security, privacy, compliance, making sure that the clusters are hardened and secure against attack. We also offer platform services like files and objects using our Nutanix unified storage. We have support for container environments. So if you're doing data services for Kubernetes, we can support those applications. And we also provide database services through automation. We do that in multiple environments, leveraging virtualized compute, storage, and memory. And that allows us to run these applications in all different environments, whether it's on-prem or in public cloud. So depending on your environment, we can run those applications and databases anywhere. Today, we're just going to focus on database automation. And if you're familiar with Rube Goldberg machines, you've probably seen these in movies. You've seen Pee-wee's Big Adventure. He makes breakfast with one in the morning. If you've seen Back to the Future, you've seen Einstein the dog and his dog food with all the different contraptions. And when I speak to customers, they talk about, well, we have scripts and we have automation for that. We've got Ansible and Terraform to do this and that. But what we tend to find is that, they'll get to the destination, right? Yes, I follow this sequence of events and I get to my database. But automation can really fundamentally change how you manage databases. It can also, not only eliminate downtime risk and speed up environments, but it can also improve your security posture. And that's what we're going to focus on today. Now, Nutanix Database Service, what is that? So Nutanix Database Service is a set of REST APIs, and command line interface, graphical user interface, and K operators that sit on top of the Nutanix core platform. This allows us to provide database automation lifecycle management for all of the databases that you see here, from the commercial databases that are common licensed from Microsoft SQL and Oracle, through the more open source common databases you hear like PostgreSQL, MySQL, EDB. And if you're dealing with an environment where you're dealing with AI, you need some type of vector, so PG vector capabilities, as well as MongoDB. What we're able to do is automate the provisioning, applying best practices to run in Nutanix environments, provide thin cloning, which allows us to quickly create copies for like unit testing and development teams, provide storage scaling, patching the databases, which we'll touch on today, and then fast backup and recovery. We do this leveraging either our integrated Acropolis hypervisor, our own integrated hypervisor, or if you wanted to bring something from a third party like Broadcom's ESX, you can bring that as well. And we can do this on-prem or in public cloud in AWS and Azure. So what if you could fully deploy your configuration of a database in minutes instead of days? What if your teams could focus on strategy instead of firefighting operational issues like database recovery in the event of an attack? What if patching and scaling happens seamlessly with no impact on performance? And what if you could improve the security posture of your database environment in a simple and predictive manner? That's what NDB provides, that level of automation. We also will allow you to integrate, if you have existing Ansible scripts or Terraform, you can integrate those into our automation processes as well in pre and post scripting. We're also joined by HYCU. So Chris, if you want to say a couple of things briefly about HYCU and what your capabilities are, that'd be great.
Yeah, so we're one of the only, or if not the only vendor to support enterprise level backup and recovery for Nutanix Database Service. So obviously we're going to have a bit more time after Georgia has gone through all the amazing stuff that NDB does on cybersecurity for databases. But essentially we're kind of the backup, enterprise backup and recovery for Nutanix essentially. Yeah.
Awesome. Thanks, Chris. So again, if you're leveraging container environments and containerized apps, you can also integrate those into the database environment, leveraging Kubernetes, OpenShift, and NKP as well, which is our own Nutanix Kubernetes platform. First thing we're going to touch on is misconfigured database settings. So let's talk about that real briefly. And that has to do with provisioning and security compliance. So as I mentioned, the Rube Goldberg process, right? I speak to customers all the time and they say, yeah, we have a process, we request it, it goes to our database team, then our infrastructure team, et cetera. And they all have their scripts and processes to do that. And that's all fine, except there's typically still manual sequential processing. I spoke to a large organization in New York City recently. They had 900 databases. And when I asked them, how long does it take to spin up like an Oracle database, like a simple database? It takes them 2 to 3 weeks to get that database operational. The challenge with that is if you're doing that over and over again in your line of business, that can lead to lots of unpredictability. You have multiple steps and teams, and there's friction and complexity. Now, sure, you may be automating some of this, and there may be scripts that the InfoSec team runs to check for compliance. But this does decrease the innovation rate. What if you could do that all where the DB customer requests that through the database team, and now all of those teams' policies are applied, and they can be done some sequentially and some in parallel all at the same time. So for example, software profiles to determine what database engine is running, compute profiles that determine the compute memory and storage of the database itself, network profiles to determine what network the database should reside on. And then the database server VMs themselves, along with all the hardening and configuration, like the HA configuration of the database, all that stuff is done at the time of execution. That takes minutes, one person instead of multiple teams waiting. But again, they're all influencing the golden images that are used and deployed. But this eliminates friction. It makes sure there's consistency and it improves security posture for your organization. As I mentioned, in provisioning, you can do things like t-shirt size, where you set the size of the database XL, large, medium size, based on the amount of compute, the virtual CPUs, the memory, and you can also allocate how much storage is provided for that. And you can scale these things and modify them later, but you do have a baseline provisioning that you can set up, as well as the operating system and all the underlying capabilities. Now, as I mentioned, it's it's a RESTful API toolkit, right? All the automation is based on REST API. One of the beauties of our platform is we integrate into development environments very well. If you're already using some type of an automated tool, if you're using ServiceNow or other tools, and you might already have scripts, you can also look at everything that we do in the user interface in its equivalent form. So you can get access to Python or PowerShell versions of those API calls. So you could literally integrate this into an existing interface in an environment where you're already automating things today. Next, we're going to talk about patching and security. This is one of mine that's near and dear to my heart because we have had customers who have brought us in for this specific reason. And why is that? When you look at the key statistics, 61% of breaches involve known unpatched vulnerabilities. This is from SANS. A lot of the failed audits are due to database misconfigurations or outdated versions, meaning they weren't patched against a vulnerability. 99% of exploited vulnerabilities are known for over a year from Gartner, and then 60% of compliance audit failures tied to unpatched software. Chris, do you want to say a couple words about this? I don't know if you have anything to add here.
Yeah, I was quite shocked when I saw your slides come through and we were working together on this. That these are shocking numbers, right? Everyone's worried about the 0-day attack and how do I get my seams sore and my CrowdStrikes, my SentinelOnes, and all these things to kind of buzz an alarm, and my socks and all these things. And this is real basics, right? This is going back to kind of, hey, patch your stuff. When someone says there's a vulnerability, patch it, and we can stop half of this stuff by better patch management. And this kind of falls into what I'm going to talk about later is like, well, actually, once they're in, now they're in, 61%, 50%, 99% they're known. So they know how to get in, and it can be repeatable. And they're dropping these known payloads in, right? So how do we then figure out what they've dropped where? And I'm going to talk about that a little bit later on.
Yeah, absolutely. And that segues perfectly into the outdated software and patches. And when we look at what we're talking about here, it's common vulnerabilities and exposures, or CVEs. When you look at all the different database vendors, whether it's Oracle, SQL, any of them, and I'm not picking on anyone, there's vulnerabilities over time, and every year new vulnerabilities get discovered. And that's why we see these announcements that, hey, there's going to be service patches, there's going to be critical update patches that must come out. Here in this example for this database manufacturer, they come out quarterly. They come in different levels of severity, but these common vulnerabilities and exposures, the higher ones need to be patched, right? The lower ones may not be as critical. They may not apply to your environment, but the critical ones should be patched. And this is a very important takeaway. When we look at audit failures, and we were brought into an online retailer to help them because they had failed their internals audit. Luckily, they weren't attacked, but they had failed their internal assessment from their InfoSec team. So they brought us in to make sure that they could have consistent patching of their Microsoft SQL environment, as an example. And that's very common, right? Missing or delayed patches and updates, on Oracle SQL, others could cause that. Use of end-of-life database versions, again, making sure you're updated. Unencrypted data at rest and default credentials. These are more configuration related, but certainly could get caught in an audit. And then lack of documented or automated patch management policies. So at least on the top three, Nutanix Database Service automation covers those top three. And we can also, if we deploy properly in the golden image during time of provisioning, we can address those other two as well. The theme here, I think, is that proactive database patching is essential to pass audits and reduce breach risk. It's going to reduce your attack surface. Is patching regularly going to stop every attack? No. Simple answer, right? But will it reduce the attack surface and potential? Absolutely will. So why does it matter? When you look at this, it's fines. We see huge fines coming down on organizations who've been breached already. HIPAA, PCI DSS, SOX violations. Lawsuits in case of breach. Hey, you could have prevented this attack and you didn't take the necessary steps to patch against this. So you could be liable in that case. And then obviously there's loss of certifications, reputational damage. Loss of industry certs could be very impactful to an organization if they require those certs to operate in an industry. And reputation damage, it's hard to put a price tag on what that looks like, but it can be very significant to a company. But imagine if you could update your databases as easy as you update the applications in your phone. You simply go out and check for a new update for that SQL server. You click update, you select which update version you want to patch to. You can either do it now or choose a maintenance window. We allow for maintenance windows where you can pick times where the patch is applied. And then here you can do any pre or post commands. So perhaps you want to run some type of a script before you actually apply the patch and then run another test after. Maybe you want to run after the patch is applied a security audit to make sure that you maybe have the test to verify that CVE has been patched. You can have it run after you patch the database, as an example. Once you're done with that, you pick the VMs where the databases reside, and you simply click update, right? It's that easy. This is an example of a traditional patch environment versus automated patching cycle. This is a customer with a 3-node Oracle real-time application cluster. They are patching, and you can see it took them 47 minutes to patch this database. That database was greater than 5 terabytes in size. You can see the fine-grained steps we go through. The important takeaways here is, one, we take a snapshot before we apply the patch, and we can roll that back. So if anything goes wrong during the patch process, we can return you right back to steady state where you were before the patch process. Typically, when you do manual processing, it's very tricky, and rolling back patches can be very, very time consuming, but we can speed that up leveraging snapshots, which is a capability inherent in Nutanix software. So we're leveraging what's built into the core platform to provide a snapshot, take a quick snap, and then recover from that. The other point to make here is that this usually took an entire weekend, 8 hours over a weekend, and 4 engineers to accomplish, and now it can be done in 47 minutes. So if you can patch more often and more readily and easily, it's going to improve your posture because you're going to be up to date more against the latest vulnerabilities, and that's very important. And also some known vulnerabilities, as Chris mentioned earlier, that have been around for some time. Clean backup and data recovery is really, really important. Now, Chris is going to talk a little bit more about the long-term backup. But when you think about backups, there's really 2 pieces to it. There's you want to have a short-term or quick backup capability, and then you want to have a long-term cold capability. I'm going to focus on the quick, because think about database backup strategies, the 3-2-1 strategy and backing up information. You want to have 2 methods, right? You want to have a quick method, and then you want to have a longer term method. Our quick method leverages a rapid point in time recovery using something called Time Machine. Time Machine is built in and allows us to replicate point in time recovery. We can refresh data from production to development environments in these DBs. We can rapidly set up and clone environments. So if you wanted to, you could actually create a clone of the database first, patch it and unit test it and make sure it's running okay first, and then move that to production or patch the production system. So it gives us a lot of flexibility. And this is, again, leveraging snapshots, which are inherent in Nutanix. Now, Time Machine is not necessarily a DeLorean. It's certainly not like Back to the Future, like I mentioned, but databases instantly recover point in time. So without any risk of delay of traditional backups, you don't have to move the data across the wire. We leverage the recovery process built inherently into our stack to recover that data very quickly. So if you wanted to recover from a day ago or 2 days ago or 3 days ago, you could do that. It's really all based upon the SLAs that you set in the system for the time machines themselves. Each database has its own time machine. So you can dictate different SLA levels for different databases, whether you want to have, daily for 14 days, or you want to have daily for 30 days. You can dictate those policies on a per database basis. What's key about this when we look at the statistics? Yeah, a lot of people do take backups. The problem is actually recovering from those backups. On average, only 57% of compromised data is recovered post-attack, meaning 43% is permanently lost. 34% of organizations take more than a month to fully recover from ransomware. Chris, do you want to make any comments here or have any comments for me here?
Yeah, the bottom one really pains me as being the backup guy, right? We pride ourselves at HYCU, we want to be able to get people 100% their data back, right? That's the idea of having backups. So I think it's really, really key to make sure you are utilizing all the tools in your arsenal to make sure you are safeguarding your organization as best possible from these attacks. They're changing, they're constant. So what you did a year ago, what you did 2 years ago is not going to be sufficient for today's attacks. It's about leveraging all the pieces of the puzzle to make sure you are resilient enough to recover. And we talk about recovery, restore. I like the term cyber resilience, right? It's about how do you get that minimal viable business back up and running as quickly as possible. That might be from using Time Machine, right? That might be one thing for your databases. But then how do you get your apps back on, all those types of things, right? So it's about understanding and planning. It's unlikely that they're only going to go after your databases, right? I know we're talking about NDB today and all that kind of stuff, but it's unlikely. Like if they get into the platform, they're going to go as far and as wide and as deep as they possibly can. That's the idea of what these guys do. So it's about planning and testing as well. And that is a great thing about the Time Machine and the way that we work with Time Machine at HYCU as well, is that you can test this stuff on a regular basis, like George was mentioned about the instant cloning and all that kind of stuff, right? Making sure you are testing your recoveries, testing all of these bits and pieces as part of your cyber resilience planning. And patching and security and database posture management, all those things come into your testing and your planning as well. It's not just about what happens when I get hit, right? It's all those things previously that to make sure your cyber resilience is as good as it can be.
Absolutely. Yep. Couldn't agree more. So when we look at that, what are the financial consequences of that? Well, backup compromise doubles ransom demands and leads to 8 times higher recovery costs, right? So if they can get access to your backups and damage those and make them unrecoverable, they're going to get more out of that from a financial perspective. Failing to restore from backups can add as much as $190K in additional ransomware claim costs. And so I think, the key here is effective backup strategies are essential, but underutilized. That's according to Gartner, right? That, we're not backing up enough and we're not validating that we have protections against those backups. So we need to make sure not only that you are backing up, but that those are safe and secure as well.
This is likely to impact your cyber insurance policies as well, right? If you're not backing up properly, that's the first thing they look at. Or how come you couldn't recover, right? And they go, oh, you weren't backing up properly, you didn't test it. Oh, sorry, we're not paying out your $5 million claim, right? Like that's real life. You start looking at this. I've looked at cyber insurance policies for the last 3 years, and every year they get stricter and tighter, and the clauses become so almost inherent of what you have to do. You have to back up this many times. You have to follow this 3-2-1-1-0 rule, all this type of thing. So, it's making sure that you understand those policies as well, because a lot of people think that is their strategy. That's why I've got insurance that covers me, right? I have car insurance. I don't go out to crash my car every day, right? I try to do everything. I do everything possible not to crash my car because I don't want to deal with insurance companies, right? And that's kind of the moral of the story, right? Do everything you can not to get attacked, and if you do everything you can so you don't have to deal with the insurance company.
Absolutely, absolutely. And if you have to, you have to. But it's there for your.
Agreed. Yeah. It's going to mitigate some of that financial risk, right? Potentially, but it's not. It can't. Money can't solve the reputational damage and the downtime that's been caused, and potentially loss of data as well.
Absolutely. So let's just quickly touch on, because I want to give Chris some time as well. He has some things he wants to share on the deeper stuff that we just mentioned. So native point in time recovery. This is an example of a real customer. They had a point of sale system, Microsoft SQL. This is not actually a cybersecurity breach, but it's analogous to what would happen, right? So they made a change manually to their configuration. It took the drives offline, so they lost access to the data. The database actually lost access to the data, which is scary, right? And the manual process to recover following Microsoft's procedures would have taken them approximately 10 to 14 hours. That's estimated. We don't know what it really would have taken them, but estimated 10 to 14 hours for recovery of this 14 terabyte database. Because why? You have to do the native backup has to move across the wire and it has to restore across the wire. That backup file takes time to move. Because we had the Time Machine and we had recent snapshots, which don't consume memory, that's another key takeaway, right? So some of our customers have seen as much as a 50% reduction in storage because they're not doing full backups all the time. They can leverage snapshots in between those larger copies, those longer term cold copies offsite, and have something quick that they can restore from fast. And so we had that more recent copy, so we were able to recover in 15 to 20 minutes approximately. It took more time, I think, for them to call our support and figure out how they were going to do this, and then it did to actually do the process. But ultimately, the full recovery time took approximately 15 to 20 minutes. Why is that important? Because this is a retail customer and they had a point of sale system that was running all of their retail branch locations across the US. Very, very important that they get that back online so that they can actually get revenue. So that was just one example where this could come in, sort of having this quick recovery mechanism using snapshots is kind of like that save your bacon moment where I can really save the company a lot of grief and pain by having that fast recovery. This also ties into development environments. We leverage the same capability that we use for backup and recovery for creating clones as well. So this is all interrelated. Now, this is actually a customer's measured data. They did their own environmental test of a 2 terabyte database using a traditional backup tool. It took them about 2 hours to recover that 2 terabyte sample set. They leveraged our snapshot and they were able to do it in minutes. And they actually did a test against a 40 terabyte database themselves. And after 16 hours, they gave up on the traditional backup recovery tool. We were down to like 8 minutes, 9 minutes, and we were able to recover that larger data set very quickly. But this becomes important when you want to give developers copies of the databases, because that's another thing we can do. We leverage the same capabilities to create clones of the databases. We maintain the state of those clones. So you can create clone copies, and you can also run pre and post scripts to obfuscate the data. You don't want to hand a developer a copy of a database with that mission critical intellectual property on it, customer, credit card numbers, things like that. So you want to obfuscate that and mask it. And so you can run your data masking script. So when you create a clone, it's automatically masked to a team, so that you don't have to have a DBA go and run a different set of tools and then provide a masked copy. You can do that automatically. So there's a lot of power behind this. It's not just security. It also speeds up development and automation and unit testing as well. So why does this all matter? I mean, from the business driver perspective, we're going to reduce risk of human error and downtime. We're going to lower operational costs and inefficiency and accelerate innovation and time to market. I think it's pretty obvious to everyone that automation speeds these things up. But the broader impacts to this are really relevant, right? It enhances compliance and security posture. And we miss that a lot of times. We speak about how fast we can deploy a database or how quickly we can recover from a failure, but we forget about patching and the security posture and maintaining that as well. And we can do all of that. It overcomes scalability and flexibility barriers because we can automatically adjust the storage and memory and things like that, and scale the databases out by simply adding more compute to it. And it frees teams to focus on strategic initiatives, which I think is very, very important. So we have great resiliency options, but third-party backup is still required for multiple cases, especially when it comes to compliance. And I'm going to turn this over now to Chris. He has some more things to talk about. So Chris, I'm going to let you take it away from here.
Yeah, amazing. Thanks, George. Massive insights, and I've learned a lot already. So thank you very much for that. So third-party backup options are still required, right? For all the reasons that George had mentioned, so for compliance and archive and all these things. So we're going to run through those in a sec. But up until I'm going to say now, but we released it a few months back, there were no supported options for NDB, right? Nutanix had this amazing platform that did all these amazing things, but there was no integrations from any of the vendors. So HYCU and Nutanix have a long history of working together, which again you'll see in my slides in a minute. And we developed the world's first NDB-aware or NDB-supported enterprise backup solution. So what are those kind of use cases that are using Time Machine versus the third-party solution, right? This isn't a rip and replace, right? There's a reason that me and George are presenting together, right? Because they work hand in hand, and they need to work hand in hand, right? Time Machine is an incredible piece of technology that is going to save customers huge amounts of time, and it will, save you for database errors and file and OS corruptions and human errors and all these things as well. But as we start moving throughout this, these different use cases, we start looking at things like human error, right? Human error could impact just one database, but it could impact an entire Nutanix cluster, right? And at that point in time, Time Machine sits on the Nutanix cluster. So if you can't access it, or you can't do anything with it, right, you can't use it, right? So this is where someone like HYCU, where it's going to take the data potentially outside of the Nutanix cluster, put it somewhere in a separate tool or in a separate entity you restore back in case. Compliance needs multiple. I mean, I'm from the UK, if you can't tell from my accent. DORA and all these other things now are coming in and requiring, offsite, off production copies of data. And that's not an optional thing, right? If you want that certification, you have to have it. Has to be immutable, has to be off production, right? That 32110 rule that we've spoken about many times. Cyber attacks, it could fall like slap bang in the middle of this, right? Luckily, maybe you get 1, 2, 3 databases or your entire NDB, right? And you can use Time Machine to go back. But as I mentioned earlier, if they've got a hold of all of your databases, it's likely they're going to get hold of everything else, right? So we can use NDB and Time Machine to rewind those databases. but then HYCU can help you rewind all the rest of your infrastructure on top of that as well. And if you can't, for whatever reason, use a time machine, you can still use HYCU for those NDB ones as well. And then you start looking at disaster recovery and offsite requirements, and then long-term retention archive, right? Time machine's amazing. It doesn't want to store data for 7 years. That's not what it was designed to do, right? It wasn't designed to keep data on the platform for 7 years for compliance reasons, right? It was there to give you the quickest possible recovery from whatever happened to your databases, right? So these are all the different use cases that HYCU covers essentially. So as we start looking at HYCU, I'm really, really aware that people may not have heard of us before. Everyone's heard of Nutanix, and you've probably joined this because you know who Nutanix are. But if you don't know who HYCU are, we've been around for a long time now, so we're globally recognized and trusted. We got, I think it's actually over 5,000 customers now. When the slide was created a few months back, over 80 plus countries and 450 channel partners, and big investment firms and some of the biggest names in tech have well invested in HYCU and kind of see the vision behind and the passion behind our project. And if you didn't know, we are the #1 data protection platform for Nutanix. That's where our heritage is. That's where our DNA is. So our first ever platform that we did data protection for and we built was Nutanix. Everyone else was focusing. This was like 10, 12 years ago, by the way. Everyone else was focusing on VMware, right? The big players in the game, and you see all these other vendors who focused on VMware, right? We focused on Nutanix, and that's why we have the best integration, the best relationship. We work hand in hand with their development teams on all these solutions as well. And then you look down the stack here, we have one of the best, or if not the best, probably going to say it, the best net promoter score in the data protection industry as well. And that matches, again, what Nutanix do. Nutanix pride themselves on their NPS score, and so does HYCU. We match both of them in the 90s. And then moving on to kind of the pieces that George mentioned earlier, right? You need to have that strong foundation, right? Patching and posture management and configuration management. HYCU is one of the world's most kind of securest data protection platforms. So we have military grade security, and we're the only data protection vendor in the world to have a DISA STIG. If you're outside of the USA, a DISA STIG is like essentially a defense agency who will certify that software can be used in military, right? And they give you a STIG certification to say, yeah, this is ultra secure and it can be used by any of the military or any of the 3-letter agencies in the USA as well. On the right-hand side, you can see the integration we have across not just NDB, but also NKP, which George has mentioned earlier, NC2, NUS, as George has mentioned, Robo, Prism, Calm, Metro, and again, both hypervisors support as well, AHV and ESX if you want to bring that on top as well. So you can see they really do go hand in hand. All the products and bits and pieces that make up the Nutanix platform that George mentioned earlier, HYCU supports down that journey as well. So we're not just a point solution for just NDB or we are end-to-end, Nutanix data protection, born and bred. And we protect that using our platform called HYCU R-Cloud, short for Resiliency Cloud, if anyone's really interested. But what it gives is total visibility, total protection, total recovery, and total control. And what do those really mean? Well, essentially, we have app level discovery. So inside of Nutanix, you can set up HYCU to go and look at all your virtual machines, tell you what you've got running on them. Obviously, if you've got NDB, you're going to know you're running SQL, Oracle, Mongo, whatever it might be. But we can then go and discover Exchange, Active Directory, those types of things, so you can protect them differently. And then we've got the total protection, all the backup and recovery and compliance and archives that you'd expect, and the cyber resilience features. And then we have the operational recovery and disaster recovery functionality, and then the hypervisor cloud migration if required. We're seeing a lot of traction from VMware customers moving and migrating into the Nutanix ecosystem right now, and also people repatriating down from the cloud as well. And then you look across the bottom, across total coverage. We not only have incredible coverage in Nutanix, but also incredible coverage across the entire data estate as well. We understand that most organizations are going to be running a Nutanix plus some SaaS plus a bit of cloud, right? That's why NDB works across all these public cloud and containerized platforms as well, because they understand that not in an ideal world, everyone will be running Nutanix solely, right? We understand that this is the hybrid world we live in. There's going to be different use cases for different applications and different technology stacks. But you can see across here, even into AI ML workloads, so there's vector database that George was mentioning earlier, HYCU can also back those up as well. So you can see the synergies again coming through. As I said before, we pioneered the Nutanix data protection industry. And as I build this slide out, you'll see that we at HYCU were the first to deliver protection for AHV, giving rapid restores, first to protect Nutanix files, first to protect volume groups, first to protect ESX, to store data with object lock on Nutanix objects, first to do AHV Metro, first to with the co-developed API for Nutanix files, and first to do NDB. You'll see there's a very strong heritage and a very, very strong roadmap forward. So essentially, wherever Nutanix is going to go, I didn't see generative AI and AI being this kind of big 5 years ago. If anyone did, fair play to you. Hope you got shares in Nvidia. I didn't see it 5 years ago, and who knows where it's going to be in 5 years' time. But wherever Nutanix are going and building those blocks, if they have data on their platform, you can bet the HYCU is going to go on its way to supporting the recovery and backup of that as well. As I mentioned before, if you are looking for a data protection provider for Nutanix, we are the ultimate Nutanix data protection solution. So obviously we're talking about databases here, being the one and only NDB solution out in the marketplace that supports all NDB databases, not just a subsection of them as well. So let's run through our overview of HYCU for NDB. So it was purpose built for NDB. This is using Nutanix built-in APIs, right? We co-developed with Nutanix on this. So, we hooked up with their developers and said, hey guys, we're trying to protect this. What do you suggest we go about it? Here's our thoughts. How do you think we should do it? Also, how do we make sure we protect and recover so we don't break anything, right? That's really, really important. I'll get onto some of those bits later on. So no agents to install, no in-guest things to run, completely independent, completely native to Nutanix. And I said we were the first backup recovery for NDB. And it's one-click simplicity. So just like George mentioned with those kind of like those policies, and you can go, okay, we've got compute policy, network policy, etc. You can now just have a backup policy with HYCU as well. One policy that dictates everything. Automated. We can have a default policy if you want. So as soon as an NDB DB gets spun up, as George mentioned, we can do those in minutes, right? You don't want to have someone sat in HYCU constantly going, right, add to policy, add to policy, add to policy. It would just take forever, right? Well, guess what? Using the automation in the Nutanix platform, you could even automate HYCU to add it to policy, or it will land on a default policy. And if we take a little kind of double click on here, so what do we actually do? We remove those manual backup processes. As we mentioned, HYCU will automatically discover and then continuously protect any new or existing databases. So as George mentioned, if those guys are, in those teams are requesting 10 SQL databases a day and they're getting delivered in hours rather than weeks, the guys haven't got time to sit there and manually add things to HYCU or any backup provider, right? They haven't got time to do that. Or things get missed and things get, out of compliance, etc. Well, HYCU don't have to worry about that. It's going to be automatically caught, automatically protected. There's no workarounds, no coding needed, right? So we followed Nutanix's best practice and all their advice around the snapshots of disks and volume groups. And by the way, HYCU is the only ones who support volume groups for backup and recovery in the marketplace. And volume groups are used quite heavily in NDB. We're the only ones who can do that. But also, there's no then, oh, by the way, you can back this up. But if you're restoring it into NDB and with Time Machine, you need to run this script before you do it. That in time of crisis, people haven't got the clarity of thought to worry about that type of stuff. So it's a case of, okay, it needs to be simple, it needs to be repeatable, it needs to be easy to use, right? That's exactly what we do. We give you a nice interface, click, restore, done. It's very, very simple. And then we can eliminate misconfiguration with our native integration. And this really comes down to kind of George's point about automation, but coming down to not letting people make decisions they shouldn't be able to make, right? We don't want to let potentially, we don't want to let a developer choose the size of their VM, right? Because they're going to choose 200 terabytes of RAM, 5 terabytes of disk, and 50 CPUs because they want it to run as quickly as they can, right? But obviously, if the infrastructure guy says that's not possible, so it will come down to this type of risk management. So at HYCU, we make sure that whatever we do with NDB doesn't break production, and when we restore data, doesn't break Time Machine on the way back in as well. So things like log management in databases. Typically, outside of an NDB database, a lot of the people use their backup tool to do log management, log truncation, etc. Right? But because NDB manages that process, if you turn on log truncation in your backup tool, or it's probably already turned on in your backup tool, because they're not NDB aware, they don't know it's being managed by Nutanix. That's just going to break NDB completely. It's not going to let you use Time Machine. All those benefits that George mentioned about Time Machine is going to completely go away because your backup tool is trying to do the same thing that Nutanix is trying to do, and those logs just get completely confused because two tools are trying to do two different processes on them, right? NDB agent disks. Okay, this is like real sub-level, but when you add in an NDB database, they get agent disks. These are automatically excluded from the backups. This isn't, again, a step you have to worry about as a configurator or an admin, because if you do back them up and you do restore them, if it's not done correctly, you're going to break production. You're going to put it back in, you're going to break Nutanix, you're going to break things like Time Machine. These things aren't going to be working because they weren't designed to be put back in in that config, right? You have to understand the kind of the complexities and the NDB is so simple to use, but it hides all that complexity around, behind the automation. That's the beauty of NDB. But if you don't understand the complexity of all the things it's doing in the background, then you don't understand how you should restore and recover data into it. And then we connect the dots afterwards, right? So we make sure NDB continuity and manual effort afterwards. So we do things like we replace disks and not whole VMs where possible, right? Because if we can just replace a disk on the NDB server, it's going to be far more efficient than replacing the whole VM, trying to re-register it, add it in, look at with brand new IDs and all those types of things. It's going to become far easier. And then we trigger NDB to then clean up the new disk IDs. So it uses Nutanix replication for Time Machine, as George mentioned earlier. And Nutanix replication uses a thing called protection domains. And if you haven't updated the protection domains, Nutanix replication doesn't work properly and Time Machine doesn't work properly, right? And the reason you're going to find this out is when you need it the most. So when you've recovered a database using a HYCU and then you go, I screwed up that table. Let me just use Time Machine. I can go back 20 minutes. Don't worry about it. It's cool. Time Machine's broken. Oh my God, now I'm going to go back. I'm going to have to go back like a day or 2 days or something. Like I'm going to have to go back to my last copy. I haven't got that safety net anymore, right? And these are the things that you don't realize. Again, HYCU is very simple to use, but it hides all that complexity behind its interface, exactly like NDB does. And if you don't understand what's going on, it's very easy to make these mistakes and not realize you're making mistakes. NDB databases, they're kind of special, right? They work in different ways to normal databases. If you take your normal database backup and recovery processes, apply them to an NDB database, you're likely to break something. Because you don't know that. Yeah, George, go ahead.
Can I just add something? You made a really good point, and this kind of harkens back to the beginning of the presentation where I said databases are hard, right? And very complex. One of the things that you touched on here is really important to point out, right? Utilizing Nutanix best practices. You can take, we have customers that have just taken databases and natively moved them on to Nutanix and they run them and they're running and they're functional, but you will not get the best performance. Things like leveraging volume groups is very, very important when you're dealing with distributed storage, right? You've got compute power and distributed storage across an entire fabric of available hardware in a given cluster or in a public cloud environment across the hardware in those public cloud environments. And you need to make sure you apply these. So that, yes, you can just move a database over and run it in a virtualized environment, but if you really want to get the best practices applied, the best possible configuration in terms of performance, it's best to leverage a tool like NDB because we have those best practices built in. Just like HYCU has the best practices for recovery built in and for how they do the backups, when you use us to automate the deployment of the database from the very beginning, you're also making sure you're applying those best practices for performance out of the gate.
Exactly that. And that's why you choose a solution like Nutanix and NDB jointly, right? Because the heritage, the co-development and the integration between the platforms, if you use their best practices and you're using them, HYCU's going to work with those because we've identified what people should be running in there. So we're going to work on it in the best way possible as well. So if you're running NDB properly, HYCU's going to run properly as well, right? So that's kind of our integration into NDB. So now let's take a quick look at our cyber resiliency features. See if I can move the slides. There we go. So we have a cyber resiliency fabric called R-Shield. And this is a fabric. It runs through everything we do at HYCU. So it's not just a point solution or a bolt-on or a separate SKU you have to buy or anything else like that. Essentially, it's a complete fabric that runs through the entire product, the entire company, the entire ethos of what we do. And those things are based upon 3 pillars: always protected, always observing, and always ready. So let's take a look at the first one, which is the always protected piece. So we've got our platform, which we had earlier, and you can imagine R-Shield is just this kind of safety net around the outside of it, right? It weaves into everything we do, but it's kind of this safety net of cyber resilience around the outside. And as George mentioned earlier, a nice stat that backs you up here, George, cyber criminals target backup infrastructure. They go after the golden egg, which is databases where all the data is kept, and the safety net of backups. Because if you get those two, you have no way out, right? You have to pay the ransom. So in this the Backblaze report here, 93% of ransomware attacks targeted backup repositories. That was an active target in there, not just something they stumbled across, actively targeted those. So we want to make sure that we're as secure and as resilient as possible, right, from a backup standpoint, because we are your last recovery point, right? And if you can't recover from Time Machine, you're going to be going to your backup to recover from. So, but legacy backups unfortunately introduce risk and larger attack surface. George has mentioned this many a times. If we reduce the attack surface, we're not going to reduce it down to a 0% chance, but we know we're going to reduce it down drastically, right? So if we look at legacy infrastructure, so we're looking at the ways that legacy providers provide protection for, hypervisors, databases, VMs, etc. Right? We have backup servers, then we have agents, and we have proxy servers and gateways and repositories and hosts and all these different multiple components running on different operating systems, running on different versions, different patch levels, different code levels, right? They're very easy to find because they're very chatty on the network. Everything has to talk to each other, right? So if you're looking for the backup system, well, if you get into one of these things, right, even through an agent, you can see that's talking back to this IP and that IP tracks to this IP. So you can kind of piece the bits together, right? And okay, here's my backup. Every different component is running a different operating system, potentially a different patch level, different code level. So there's a massive chance of CVEs, right? And we see this across, every company has CVEs, but some have more than others, and some have more critical ones. Especially in a backup product, you don't want to be tinkering it too often, right? You want to kind of set and forget it, but also you don't want to have to be patching it and taking it down every 2 weeks for vulnerabilities. So you want to make sure it's secure as possible. And the more components you have, the more patching you have to do, the more maintenance you have to do. And George has already explained the difficulties with patching and maintenance if you don't get on top of it, right? So at HYCU, we like to have a near zero attack surface and resilient infrastructure. So we have a purpose-built virtual appliance which is pre-hardened out the back, out the door. So you install that into your Nutanix environment. It's a very lightweight machine, one VM rather than potentially 10, 15 different components all scaled out. Zero design architecture, you just put it in. You don't have to then scale it or understand how it works. You put it in, it uses the native APIs. So it's purpose-built for Nutanix. Pre-hardened, as I mentioned before, so with secure isolated network, we have continuous backup posture management. So if you're storing things on like a Nutanix a NUS cluster, for instance, and the object and the bucket, if that bucket suddenly becomes public, because a bad actor's got in and enabled public access to that bucket for a future attack, HYCU is now going to tell you that bucket is public, whereas before it wasn't. So we kind of got that ongoing that posture management to say, hey, by the way, something's changed. Or if you've configured it and configured it wrong, it's by the way, guys, this bucket shouldn't be public, right? Because it's got your backup data in it. And I mentioned before, we're military grade battle tested. We've got the DISA-STIG certification, common criteria, NIAP, SOC 2 compliance with one of the, I think maybe even the only data protection that supports VTPM on Nutanix as well. So for those Windows 11 installs or those installs where you need those trusted platform modules on those machines, again, we can back those up, no problem. So we look at always observing. This is where some of the cool stuff really comes in. So we're looking at detection here. So this really comes back to that clean recovery point that George was making earlier. Backing up data and recovering data, like for NDB, can be difficult, but in most parts you'll be able to recover some data. But how do you know it's clean, right? This is where the really cool stuff comes in. So we have a two-pronged defense. So this is kind of like the pre. Most backup products are going to be looking at the post. We're looking now like kind of pre and during attack. So we're looking for anomaly detection or indicators of compromise. So things like backup change rates and those types of things. So if your SQL database was 2% change yesterday and today it's 98%, maybe something's going on. Maybe something has encrypted some database. Maybe it's your sysadmin who has actually just turned on encryption on the database. Fine, no problem, but it is anomalous compared to what we're used to. So we'll flag that. Then also we have malware scanning or threat hunting if you want as well. So you can go into, and including NDB virtual machines as well, we can go in and do a full scan of your data to look for malicious data. So look for those payloads, look for things that aren't supposed to be there in those virtual machines, and then report back. And then we can look back and go, oh, this point in time we took yesterday, we scanned it, it's not clean. Don't recover from it. So we mark it as red in the UI, right? Doesn't mean you can't do it, because maybe you want to recover it to a clean room to see what's happening. Maybe you want to send it to your red team for them to investigate. But we mark it there, so when you've got that critical moment in time, red, no go, green, go. Clean data inside that environment as well. So we've kind of got that two-pronged defense, and you can kind of combine those and go, okay, we had some anomalous activity, and we've got a red warning on here. We really need to look at this because something is probably going on. And if we look at the anomaly detection, so it's policy-based detection. So it's not run individually. You don't have to do anything. Essentially, you assign it a policy, and that policy then can be assigned to your overall bigger policy. So you essentially go, I want all these machines to be backed up on this policy, and I want you to detect based on these metrics. Okay, done. You don't have to manually run it or manually spit it up in a lab and run that. We give you instant alerting, which then can be put into any CMOR source system. We do dynamic calculations. It's analyzing real data, not just the metadata calculations. And we also give you this backup storage independence. So we don't have any reliance on any external storage vendor. So we don't have our own appliances, our own storage, or anything else like that. We have loads and loads and loads of customers who use Nutanix objects for their backups. And this is going to work perfectly with Nutanix objects as well, or any other backup storage you can think of either. And if we look at our malware scanning, so you can see here, you can see that we're running our YARA results. I've got it actually in my Teams notification here to tell me that my VM's been infected by something or has got something here. So we're doing rapid detection. And you know those snapshots that George was mentioning earlier, how quick they are and how efficient they are on the system? We're using those same methodologies, those same snapshots to do for scanning. So we're scanning in the Nutanix cluster before we take the backup, and then we're doing it, right? So the backup process happens, and then we scan the data on the snapshot. So we're not impacting your backup, we're not impacting your production workloads. It's such a unique way of doing it. Data always, always, always stays with the customer, never leaves their control. So if you look at other vendors, the way they do threat hunting and scanning, take your backup, send it to their cloud, scan it, and send you the results. A lot of customers are going to have question marks raised over that because data is leaving their jurisdiction, right? It might just be metadata, but it's data nonetheless. And again, double protection with those two ways of detecting data. And then, as I mentioned before, this is kind of how it works. We take a storage level snap in Nutanix, which has no impact on production workloads. We then take the backup and we push it to wherever else you want, right? So Dell data domain, Nutanix objects, cloud, in AWS, NC2 clusters, wherever, cyber vaults, whatever else you want to put it. So that's not impacted by anything that we're doing here. And essentially, we take that storage level snapshot and we scan it in HYCU, and then you get your notification alerting. So the two processes are independent of each other. So one's not going to impact the other. So if the scanning doesn't work for whatever reason or doesn't run, it's not going to impact your backup and so forth. Let me look at always ready. So this is the real big piece, right? So how do you make sure that the backups are going to work? So data validation is done of three ways, the old way, right? Manually test. This kind of goes back to what George was saying about the automation piece, right? You can manually do it, you can do it scripted, or you can kind of do like more scripted, which is semi-automated, right? But you're still going to get the end result, but they're very sequential steps, right? They're not set and forget. It's very kind of someone's still got to maintain it, someone's still got to control it, still got to own it when APIs change and all those types of things happen. All these are labor intensive, they're hard to maintain. There's no real track record of keeping them up to date. There's no way of logging the results, all those types of things. And the way the HYCU does this, again, well, policy based. As you can guess from everything else we're doing is policy based. So everything in the invalidated is 100% scheduled or it can run on demand, completely extensible. So exactly like George mentioned about those kind of pre and post bits that Time Machine has as well, exactly the same in HYCU. I mean, if you look at the HYCU UI and Prism UI, which is Nutanix UI, you'll see they're very, very, very similar. And that was built on purpose for familiarity between the two tools. So if you want to do something like check a patch level wherever else after a validation, you can do that using and you can validate everything. We have no maximum. Every single backup be validated if you wanted it to.
I think that's great. I think that's great because you've got customers who've already invested in building their own scripts and capabilities. Yeah. You can leverage that, right? So it's not like, oh, well, I'm using this new thing, so I have to throw away all the work that I did. If you've got great tools for masking that you can already run as a script, you can mask. Lots of power there. Good stuff.
Yeah, exactly. And some people like to on a validation, they want to change the IP, do this change, update service now to say that we ran a validation successfully and that ticket gets logged. And it's yeah, great, run that, do whatever you want. I'd love to say that HYCU can integrate into every single tool in the world, right? Impossible to do. So we let people just design whatever they want to do with that extensibility. Yeah. Absolutely. And this piece really harks to what George was saying earlier. So we use the exact same methodologies that Time Machine uses for our instant restore process as well. So whereas others in the field will mount NFS mounts to Nutanix and restore that way, we actually use the inbuilt platform, exactly the same as how NDB does, right? We're using the snapshots. So we have HYCU owned snapshots. So whereas the NDB ones will be owned by Nutanix and owned by that the cluster, we're actually owning them ourselves. And then we restore the data exactly the same, directly back into production. So we can get the same kind of restore speeds that George was talking about with NDB for all those other applications as well, right? So if you have an app server or a database you haven't enrolled in NDB now for whatever reason, you can still use the really, really quick restores that are available using Nutanix Snaps for that. And the last but not least, is recovery to the cloud. So this is the disaster recovery use case I was speaking about earlier. So this is my last slide, so I'll make it quick. If you do need to recover data cross-cluster, cross-platform, cross-hypervisor, HYCU has you covered across this. So it's all a support for all major public clouds, including NC2 on those clouds as well. So if you are expanding your reach out to NC2 in those public clouds, you can use HYCU to back that up consistently and move it as well. And we don't have any idle compute costs. So we're not sat there running in AWS constantly costing you $50,000 a month just to run it there just in case, right? Completely idle, just storage costs. So that's all from me. I think now, we're going to go into some Q&A. So over to you, George. Hand it back to you.
Awesome. Thanks a lot, Chris. we're gonna go ahead and take a look at the Q&A. If you have any questions and you haven't asked them yet, please go ahead and place them in the Q&A. And while we're doing that, I'm going to leave this call to action up. So you have 2 QR codes. If you want some more introduction and information on the Nutanix Database Service, you can click the left one. And I would hope you'd also want to get more information on HYCU's R-Shield and their introduction there. So you can scan either of these. We'll leave these up while we do the Q&A. We did have one question that I had answered previously, and that was a great question from Adam. Adam had asked, can you use COM to automate deployment? And so we do have an automation tool called COM that's built into the Nutanix Core platform for doing automation of lots of different tool capabilities. And you can actually deploy using COM. I just mentioned to Adam, the key there is to make sure you apply best practices, things like disk volume groups and other things. We do have well-defined best practices out there for each database engine. The key takeaway for us is when you use NDB, those best practices are implied inherently. It's built into our code already. So that's already done. So you don't have to think about those things. If you're going to automate it yourself, you just have to think about those things. How am I going to apply those best practices? It does get a little trickier with some other things, if you're going to do patching, that gets tricky. And if you wanted to leverage snapshots, it's probably a lot easier to leverage what we have built into NDB already. But great question, and we do have that capability.
And HYCU actually has COM automation, so you can deploy HYCU through COM as well. So not just Nutanix products, but also HYCU as well.
Yep. All right. Wait and see if we have any questions. We have a couple more minutes here. Any other questions in here? Yeah, and there's a lot of security in Nutanix. I'll just mention that we didn't mention about cluster hardening. We do provide security technical implementation guides and automation for defense configurations. All of that can be found if you go to nutanix.com/products/security. There's a whole detailed debrief on all the other security capabilities that Nutanix offers. Today, we're just focusing on database specifics, but there's other things you can do to harden the environment as well.
Absolutely.
All right. I'm not seeing any other questions. I think we can wrap here.
Amazing.
All right. Well, thank you all for joining. Appreciate it. And please check out these 2 QR codes and follow through and get some more information. Thanks a lot. Chris, thank you for joining me today. Really good information there. Appreciate the insight from you as well.
Yeah, amazing. Thank you, everyone. Thanks, George. Thanks for having us.
All right. Thank you.
Thank you. Bye.